All right, we're going to do section 3.5, equation solving and modeling. In this section, we're going to use the properties of logarithms that we learned in the two previous sections to try to solve equations involving exponential and logarithmic expressions. And there can be more than one way to approach these problems. And so we're going to work out quite a few so that you can kind of see the general strategy that you should take. So on example 1, it says find the exact solution algebraically and check it by substituting it into the original equation. So here we have 36 times this exponential expression, 1/3 to the x over 5 equals 4. The first thing I want to do is get the exponential expression by itself. So I'm going to divide by 36 on both sides. So this is going to give me 1/3 x over 5 to the x over 5 equals 4 over 36 reduces to 1 over 9. Now it's really helpful for me to continue to write this 1 over 9 as a fraction because can you think of a relationship between 1/3 and 1/9, something that we could do there? Isn't it true that we can rewrite x to the, or we can rewrite 1 over 9 as 1/3 to some power? And what power would that be? Well, we can square 1/3, and that would give us 1 squared over 3 squared, which is 1 over 9. And so there's a property where if I have 1/3 to some power equals 1/3 to some power, because those bases of those expressions are the same, we can just take the exponents and set them equal to each other. So x over 5 would equal 2, because that's what our two exponents over here are. X over 5, 2. And then we just would solve this by timesing by 5 on both sides. So x equals 10. That's our answer on this. And then it is asking us to plug this in to our original equation to check to make sure we did it right. So that won't take too long. I'm going to plug it in on the left side here. And I'm going to work with the left side until I end up with what the right side is. Okay, so if I just plug 10 in, this is what I have. So the first thing I would do here is I would multiply in my exponent, or not multiply, divide. 10 divided by 5 is 2. Then I would say, well, I know what 1/3 squared is. 1/3 squared happens to be 1/9. And 36 times 1/9 is 4, which is what we were trying to get. So we are right that x equals 10. Example 2, again, we're finding the solutions algebraically and checking back into the equation to make sure we did it right. So in this one, we have, again, a number times our exponential expression here, 4 to the x over 2, equaling another number. So we're going to start the same way by dividing by 3. So 4 to the x over 2 equals 96 divided by 3 is 32. From here we can take two different approaches. We can actually write both sides of this as 2 to some power. So 4 is really 2 squared, and so that gives us like 2 squared to the x over 2 power. 32 is 2 to the 5th power. If you don't have that memorized, you just do a little finger math or whatever, and or calculator math and figure that out. Now what happens here, if I have 2 squared to the x over 2 power, I multiply those exponents together. So I'm going to say 2 times x over 2, which 2 over 1 times x over 2, that's what's happening in the exponent. Oh look, that's just x. So 2 to the x equals 2 to the 5th. By that same property that we used last time, we have 2 to some power equals 2 to some power, so those have to be equal. So x should equal 5. The other way that we could have done it is right here, if we maybe didn't realize that we could write these both as 2 to some power, we can use natural logarithms or regular logarithms, well, like common logarithms, whatever we want to. We take the log of each side of this and work with it that way. And to do that, you're going to end up using your calculator. You'd move this x over 2 in front, and end up dividing by log of 4 over here. Another thing you could do is you could take this and write it as a logarithmic expression. This first thing that we had, we could say that this is log with a base of 4 of 32 equals x over 2. And we're going to end up with the same thing we would have ended up down here with log of 32 over log of 4. And then you'd multiply that answer by 2. So that, see how there's multiple ways there to do it. I personally think the first way is the coolest, but you know, you don't have to take my word for it. If I want to plug this in to check, I'd do 3 times 4 to the 5 halves. And 4 to the 5 halves, well, you're taking the square root of 4, that's what the half power is, that's a 2, and then 2 to the 5th power is 32, so that's 3 times 32, which is in fact 96. Or if you were stumped by the whole 5 halves things and wanted to type that in on the calculator, I suppose you could. Example 3. Now, this time we have a logarithm, and a lot of times when they start off giving us a logarithm, the most helpful thing to do is to switch it to an exponential equation. So we start with this base when we go around, and this is our exponent, and then it equals this. It goes in a circle. And so 4 to the first power is just 4, so let's subtract 1 from each side. Gives me 3 equals negative x, which means x equals negative 3, because I divide each side by a negative. So x equals negative 3. Now, whenever I go back and plug this in, we're most likely going to want to use our calculator here. We can go ahead and simplify it a little bit and say this is log of, with a base of 4 of, that's really 1 plus 3, which is 4. Oh, wait, we don't need our calculator. If the base is the same as this, log base 4 of 4, well, that's just 1 because the numbers match. So, yes, we did that right. Hooray for us. I didn't mean to erase that quite so much. Fun. Check mark. Yay. We're going to continue solving our equations algebraically, but we may end up with decimals here. And it tells us to obtain a numerical approximation for our solution and check it by substituting into the original equation. So just kind of what we've been doing already. So, I mean, we could take a logarithm on each side here and solve, or we could rewrite this as a logarithm. Normally, if it's in an exponential equation, you're going to somehow have to use a logarithm, switch it to a logarithm, or not necessarily have to use it, but that's going to be one way to do it. So if I rewrite this as a logarithm, I get log with a base of 1.06 of 4.1 equals x. Well, we can type that into our calculator. If you have an older calculator, you would use the change of base formula, which is what I'm doing right now. If you have a newer one and it lets you plug in your logarithms all pretty like, then have at it. I'm typing this in on my calculator so I can figure out that this is something like 24.215. That's our answer. Now when we check this in our original thing, I still have that up on my calculator, and you should too. So we're going to put in 24.215 here, but I'm actually going to do 1.06 to and then I'm going to put second answer so that I didn't have to round it all. That gives me 4.1. If I didn't do second answer, I wonder what it would give me. 1.06 to the 24.215. It gives me 4.099997801, which is really close to 4.1, probably close enough that you would be able to tell, okay, I did it right, but as long as we have the second answer key, we might as well use it. Example 5, we want to start off by, let's get this e by itself. When we have e in an equation, there's something we can do that's a little cooler. We can use natural logs, which a lot of times, I don't know, it seems like it works out nicer. Anyway, 2 minus 7 here is negative 5. Let's divide by negative 3. And that gives us e to the negative x equals a negative and a negative cancel and give us 5/3. Now, the neat thing we can do here is we can take the natural log of each side. And the reason why that is neat is because natural log and e are friends, and when they get together, they go away. So that this is just negative x equals the natural log of 5/3, or I could say that's positive x equals negative natural log of 5/3, and then we do want to go ahead and figure out what the decimal approximation of that is. So I'm going to type in negative natural log 5 divided by 3, and I get negative 0.511 for my answer. And then I'm going to go back and check it. So this is one where it'd be really easy, probably easier to type in the calculator. Sometimes it's not, depending on your opinion, it's not necessarily easier to type into your calculator because it's pretty easy to work through it, algebraically. But this is one where I personally would want to just type it in. 7 minus 3 times e to the negative second answer. Notice that negative was in there originally, but our answer is also negative that we got. So you want to make sure to put negative answer or you're going to get the wrong thing. If you put this in right, you do get 2. If you don't believe me, try it for yourself. So we really did get the right answer on that.